I'm Ms. Fung. Today we're going to look at the graph of cosine functions. Previously we looked at the sine function and we went around the circle and we said that as we go around the circle we stretch that out instead and observe what it looked like. Now when we went around the circle with the sine function we use radians. Today we're going to use degrees for fun. So we go from 0 to 90 to 180, 0, 90, 180, 270, 360, 270, 360. And cos is the x value. So let's have a look at that. So we start at 0. The x value at 0 is 1 because it's a unit circle. So we start at 1. And as we move across we can see that the x value is getting smaller and smaller until we get to 90 degrees and the x value is now 0. So 90 degrees is 0. And as we move past 90 degrees, let's say 100 or 100 a bit, we can see that the x value is a little bit negative and more negative until we get to 180 degrees and it's negative 1. And then we get to between 180 and 270. Let's see what happens to the x value. We can see that it becomes less negative, less negative, less negative, so the x value, until we get to 270 degrees and we are 0. And then as we move past 270 degrees, we become a little bit more positive, a little bit more positive, until we get to 360 and we're at 1 again. So let's sketch a graph. And we can see that if we go past that, we can see that if we go past that, we are getting a smaller x value, so we're going back down. And if we went that way or that way in the x-axis, we can see that we're going negative. Sorry, we're becoming a smaller x value, so we're going down on this side as well. So again, it's a periodic function. So let's have a look at sine. We saw that sine looked like that. And let's compare it to cos. So sine had a period of 2 pi and an amplitude of 1. I'm going pretty fast because we did this in the last video already. And we're just using that knowledge to compare it to cos. So cos started at 1 instead. And we ended up at 1. So starting at 1, ending at 1. And we can see that the period is the same. It's 2 pi. And the amplitude, so from the middle to the tallest part, is also 1. Let's plot these graphs. So here we have between negative pi to 2 pi, the values. And if I was to calculate cos x, I would get these values. You can do this using the video before where we found exact values. Today we're going to ask what happens if we put 2 cos x. So what happens when y is equal to 2 cos x? Well, if x is minus pi on 2, then 0 times 2 is 0. But 1 over root 2 times 2 is 2 over root 2. And then when x is 0, cos x is 1. So 2 cos x would be 1 times 2, which is 2. So we're just multiplying cos x by 2 pretty much. So when we sketch it, we can see at negative pi on 2, we are at 0. At negative quarter, we are at 2 root 2. When we get all the way to x equals 0, we are at 2. And then at x equals pi on 4, we're getting a little bit smaller. At x equals pi on 2, we're at 0, etc. So we can see that the cos graph starts up here and ends up there, but 2 cos x has the same period of 2 pi, but the amplitude is now 2. So we describe this as a dilation of 2 from the x-axis. So let's observe other graphs. What about 3 cos x? It will look like so. So again, dilation of 3, or the amplitude is 3. What about half cos x? It will be this graph over here. So we'll have an amplitude of half, or a dilation of half from the x-axis. So we can conclude from that that a cos x, the number in front of cos, gives us the amplitude of a. What about the period 2 pi? Let's have a look. If we put numbers in front of x, this is very similar to sine. So if I have cos 2x, is going to look like this blue line here. So it looks like it's been squished up along the y-axis, or in other words, dilated by half in the y-axis. So the amplitude is the same this time, but the period is only pi. So how do you get 2 pi to turn into pi? You divide it by 2. So the period is 2 pi divided by the number in front of x. 2 pi divided by 2 is pi. Let's try 3x. Cos 3x would mean the period is now 2 pi on 3. 2 pi on 3, or 2/3 pi. See? Between here and here is 2/3 pi. So the period is 2/3 pi. So we describe that as a dilation of 1/3 from the y-axis. So remember, the dilation from the y-axis is always 1 over the number in front of x. So if you had 1/2, 1 over that would be a dilation of 2. So here we have the period of 2 pi over a half, which is 4 pi. Let's sketch some of these. Oh, hang on. Let's do negative cos x first. So negative would mean a reflection in the x-axis, and it'll look like so. And now let's sketch these. So here we have negative 3 cos 2x. So the 3 means an amplitude of 3. The 2 means the period is 2 pi on 2, which is pi. And the negative means a reflection. So let's sketch our y and x axis. Now the numbers will be 3 and minus 3 for the y-axis because of the amplitude, and the period, well, we need to include pi somewhere. We cannot go to 2 pi. It doesn't really matter as long as you have pi, because the question doesn't ask you for a domain. So we need to show at least one period. Now usually a positive graph would start from up here, go down and up, but we know there's a reflection, so we're going to start down, go up and go back down. So let's start by putting the first spot, and then after a period we know it reaches there. So a period is pi, so after a period we put a dot exactly there, and halfway there we know that it's going to be up here. And now halfway these two dots, we know we go through the x-axis, so we can put those dots there, and now we can join the line and we can keep going. So recap, draw your x and y axis using your amplitude and period, and then check if there's a reflection, and then put your spots in. Start at the first dot, put a dot where the period repeats, and then start cutting it in half and figuring out where the other dots are. Let's do another example, it'll be much easier. Oh, and the description for this one would be dilation of 3 from the x-axis and a half from the y-axis because of that 2 over there. And also there's a reflection. Let's do another example, a third cos theta over 2. Recall that we can use theta, t, x, whatever letter we want. So a third means the amplitude is a third, and our period 2 pi over a half, 2 pi over a half, 2 divided by half is 4. So the period is 4 pi. So is there a reflection? No, there is no negative there. So now we draw our x and y axes. What is the biggest y value and the smallest y value? Look at the amplitude. So it's going to be a third and minus a third. And we need the period to be at least 4 pi, so we need at least 4 pi there. I'm just going by 1 pi, 1, 2, 3, 4. So that's the scaling because it's just easier that way. So we're positive, so we're going to be up here, down and up. So up here, put a dot at the start, and then after a period, I'm going to end up at the same spot. Halfway, I'm going to be really low on the other end, so negative a third. And halfway these two, I'm going to cut through the x-axis, and halfway these three, I'm going to cut through the x-axis. So the hardest part of sketching a graph is getting these points, and once you do, you just draw a pretty line to go across all those dots. So we describe this as a dilation of a third from the x-axis and 1 over a half, or in other words 2 from the y-axis. Example 3, sketch the function between 0 and 2 for when the function is 5 cos pi t. So the amplitude is 5 and the period is 2 pi on pi, which is, what's 2 pi divided by pi? just 2. So it's just a number this time. And we have the domain, so now our x-axis has to be between 0 and 2, which is perfect because it's a period. So let's sketch that. So amplitude is going to give us the biggest and smallest y value, and then our period is going to be 2, so I'm going to put a 2 there, and since that's 2, halfway is 1, halfway is a half, so we're going by halves. So half, 1, 1.5, 2. So when you're sketching your x-axis, you try to start at a period, then go half, and then half again. So technically you're doing a quarter, but I like going by half and half again because it feels like it's an easier mental algorithm. All right, we're sketching cos, so where do we start? Sketching cos means we start at the highest point, we go to low, and then reach the highest point again. So we start with a dot up here. Then after a period, which is 2, we're going to end up there again, so put a dot there. Halfway, we're going to go really low, and then halfway of that we cross the x-axis, and halfway of that we cross the x-axis. So now we join the dots, and now we describe it. Dilation of 5 from the x-axis and 1 over that number, so 1 over pi from the y-axis. We could also describe the range. It goes from -5 to 5. Thank you for watching, and try sketching these graphs again and then check your answers to make sure that they match. You might want to try this on a scrap piece of paper to make sure that you're able to sketch the graphs, because when you sketch it, then you'll know which part you get stuck on, whether it's scaling your x and y axes, whether it's the domain, or whether it's putting the dots in. So you might want to watch it again and make sure that you follow the process. It's quite a few steps. Okay, I'll see you next time. Bye.